Hello friends, welcome again. This is section 2 in Apache Spark Basics. In our previous section, we discussed about what is Spark, about ATL, and how Spark execute the task, and also how MapReduce execute the tasks. So in this section, we will discuss few more concepts in Apache Spark, right? So we all are know Spark execute the tasks inside the memory, right? So, but inside memory, where the data actually stored, where data stored in Spark, right? So the data will stored inside the RDD. The basic unit which holds the data in Spark is RDD. So the full form of RDD is resilient distributed dataset. So the resilient means ability to recover from failures. The distributed means the data will be distributed among the cluster for a better parallel processing. So what is RDD here? RDD is a in-memory distributed immutable collection of data and it is resilient, right? RDD is a in-memory distributed immutable collection of data and it is resilient. What is in-memory? So we know Spark processes the data inside the memory for a faster data processing when compared to disk. If you see the MapReduce, so it requires more disk reads and disk writes. That's why the MapReduce is very slower than the Spark because Spark computes the tasks inside the memory and distributed. So distributed means data will split across the multiple nodes in a cluster for a better parallel processing. So the parallel processing means the more than one tasks will run in a parallel. So more parallel tasks, quicker execution completion. And also I mentioned immutable collection. Immutable means once it is created, so we cannot change the original data, right? So once created, data cannot be changed. It means once you read the data to the RDD, the original data, the, the initial data, the initial RDD cannot be modified. It can be derived to the another RDD by applying few transformations, but original RDD cannot be changed. So this immutable property for a reason, right? I will tell you. So why it has this immutable property. And also it is a resilient. Resilient means it can recover from failures. It can recover from lost data. Or so it means in the execution, if any RDD is lost or RDD is failed, it can recover from their parent RDD. Parent RDD means from their previous RDD. So we can discuss about these things in this section only. So for now, just listen. Like so, what I am saying. So what keywords I am using. So I will explain all these keywords in this section. Right. So in Spark, there are two types of operations. So one is transformations, the another is actions. All the operations in a Spark is categorized into two types. One is transformations. The another one is actions. So what is transformation? Transformation is an operation that, that takes existing dataset or RDD and it creates the new dataset or an RDD without executing any computation, right? What is transformations? Transformation is an operation that takes an existing dataset. The dataset may be an RDD, maybe a data frame or dataset. So I will explain what is data frame and dataset. So, and it returns the new dataset without immediately executing any computation. I will show you how it will create a new RDD. So without changing, like without executing the tasks. So here the transformations don't execute the task, right? So that's why this is a lazy evolution. Spark follows the lazy evolution. Transformations is a lazy operations. So why it is lazy? The execution won't happen. So even if you run the program by applying only transformations, so execution won't happen, right? So I mentioned lazy operation. What is lazy operation? The another name of lazy operation is lazy evolution. What is it? So lazy operation or lazy evolution means execution won't be happen until action is triggered, right? So what is action here? So this is the action. Our Spark start executes only when we trigger the action, right? So what it will do? So without executing the program, so what transformations will do? So instead of physically executing the program, so it keeps record the history of transformations we applied. Instead, it records the transformations in a logical plan called lineage graph. It records the transformations inside the lineage graph. The actual execution is happen only when action is called, right? So these transformations will record all the transformations inside this lineage graph. So I will show you how lineage graph looks like. So first of all, what is lineage graph? Lineage graph is a logical execution plan. So I mentioned, right? So it don't physically executes. It is a logical execution plan that records the history of transformations applied to an RDD. So it means, let's for example, you are trying to read a file and you are applying a few transformations on that file, on the dataset. Consider this flow. So first I am reading a data and I am applying a map transformation. So after map transformation, I am applying filter transformation. So filter is nothing but our bare class in SQL. Map is, so it returns the single record as input and it takes the single record as input and it returns the single record as output. So inside this map function, we can do whatever the operations we want. So I will show you in our practical section, right? So we wanted to perform these three transformations in our data. So how actually it will, so it will create the lineages. Let's for example, so we are reading a data. So it will create RDD1. It will create a first RDD. So we are reading from reading from a HDFS, or it can be a ADLS Gen 2 or AWS S3. So we can read data from any of the sources, right? Next, we have a map transformation. So what I mentioned, the transformation means transformation is an operation. It takes an existing data set, existing or like existing RDD, and returns the new RDD. So the same I will implement here. This map transformation will take the input from RDD1 and it will return the new RDD, RDD2. And for second transformation, again it will take the data from previous RDD and it will return the new RDD called RDD3. RDD3, right? Let's, for example, in the runtime. So if any RDD is failed, let's, for example, so this RDD is failed. So what it will happen? So it don't shut down the program completely. So instead, it will recreate this failed RDD2 from its parent RDD. So for RDD2, the parent RDD is RDD1. So it will recreate. So that's why it is a resilient. It can recover the lost data or failures. So now you understood, right? So why it is fault tolerant? So it will the transformations derives the new RDD for each operation. So if any RDD is failed, it will recreate from their previous RDD. And one more thing, if you see this graph, so for each transformation, a new RDD is creating, right? It is not changing their previous RDD. Let's, for example, map. I'm applying a map transformation. It is reading the RDD1 and it is creating RDD2, right? We are not directly changing data of RDD1. And also for filter, it is reading a RDD2 and creating a RDD3 by applying few filter operations or where class operations. So that's why the RDDs are immutable. I hope you are understanding. So once created, data cannot be changed, right? So our original data is not changing. Only we are recreating the other RDDs with our required transformations. Hope this is clear. So how these RDDs can recover from failures means due to immutability and resilient property as shown in this diagram. I hope you are understanding. The another one is actions. What is actions? So what is transformation? So it takes an existing data set and it will create the new data set and it don't executes the program immediately, right? So but action triggers the execution. So once you call the action, our entire Spark program will begin the execution. So action is an operation that triggers the execution, right? And one more thing, Spark actually run the job only when action is called. So you have written a program and you are not called any actions. The Spark program won't run. So instead, it keep record the whatever the transformation you have written inside the lineage graph. So this is the lineage graph, right? So transformations are creating lineage graph. And what actions will create? So actions creates a DAG. What is DAG here? The full form of DAG is directed acyclic graph. Acyclic graph. So what is lineage? Lineage is a logical execution plan, but DAG is a physical execution plan. So it is created when action is called. So whenever you call the action, this physical execution plan will create. So according to this plan, our actual Spark job execution will happen. So what DAG contains? So what lineage contains? So lineage contains series of transformations applied to an RDDs. So in the same case, what DAG contains? DAG contains stages and jobs. So I will show you. So I will execute one program and I will show you what is stages and what is jobs. Right. So I mentioned transformations and actions, right? So what are those? Okay. Examples of transformations. So these are the few examples of transformations: a map transformation, a filter, a flat map, union, distinct, and we have a few other transformations as well. So I will explain each of them in our previous sections or in our upcoming sessions, right? So what are the actions? The examples of actions are collect, count, first, take, reduce, save as text file. So this is for saving the data to the destination location, right? So I will quickly go through whatever I'm saying now. So first of all, so Spark process the data or executes the data inside the memory. So where the data exactly stored in the Spark is RDD, right? So this is the basic unit or low-level unit or low-level data set which holds the data is RDD. The full form of RDD is a resilient distributed data set. What is RDD? So RDD has all these properties. RDD is an in-memory, distributed, immutable collection of data, and it is resilient. So the in-memory means, so it means, so the Spark process or executes the uh, program inside the memory. So for a faster data processing when compared to disk and distributed. So once you read the file, the data will split across the multiple nodes for better parallel processing. And also I mentioned two important like properties, immutability and resilience. Immutable means once it is created, we cannot change the data. We cannot change source data. Instead, we can derive a new RDD. And resilient means ability to recover from failures. So how it will recover? So from their parent RDD, so it will recreate the last RDD. And also I mentioned, so in entire Spark, all the operations are divided into two categories, transformations and actions. Transformations, it just takes the existing RDD and it will returns the new RDD and it don't execute the program. So instead of executing the program, it will record all the whatever the transformations we applied into a lineage graph, right? Into lineage graph. So that's the reason the Spark we can call it is a lazy operations. So what is lazy operation or lazy evaluation? Spark don't execute until the action is triggered. So instead, it records all the transformations into logical plan called lineage graph. So here the lineage graph, it is a history of transformations applied to an RDD. So these are the history of transformations. So we are reading a data, applying a map filter, like map transformation and filter transformation. So this is how our lineage graph will looks like, right? And also, so for these two properties, immutability and resilient. So by seeing this graph, we can understand. So the Spark is not changing original RDD or original data. Instead, it is recreating a new RDD. So that's why it is a immutable. And also, it is a resilient. It means if any RDD is failed or if RDD1 is failed, it will recreate from RDD1. Or RDD3 is failed, it will recreate from RDD2. Right? And actions. So the actions, it actually triggers the execution and Spark actually runs the job only when action is triggered. So these are the few examples of actions. So only if you call these functions, actions, so the Spark executes the program. Right? So actions will create the DAG. So DAG is the physical execution plan. It creates plan. It created when action is called. So DAG is consist of stages and jobs. Okay, so that's it for this session. So in the upcoming section, so we will execute one program and we will see so how lineage graph looks like and how DAG looks like. Thank you.